What's going on, coding warriors? Welcome back to another episode of Conquering the JavaScript Interview. Today we're going to soar to the top ropes and dive right into the world of FlatMap in JavaScript. It's a powerhouse, brothers and sisters, a tool that streamlines those tangled, nested arrays with elegance and finesse. We're going to flex our coding muscles and break down this method and reveal how it can turbocharge our coding efficiency. But before we leap into the action, we're going to take a quick breather. Make sure you check the description down below for a link to our community membership. For $25 a month, you get access to all of our courses, including our front-end and back-end course, which combined together make our full-stack program. Hundreds of hours of content, dozens of real-world projects and labs you build, my Zero to Hero React course, as well as any future course updates or new courses are added in there with no extra charge to you. You'll also be in our Discord amongst a community of like-minded individuals trying to learn how to code, improve themselves, be better, and master this trade. So if you have interest in that, check it out. Otherwise, let's get fueled up and let's get ready to rumble with FlatMap. So FlatMap, it came around in ECMAScript 2019, and it builds upon the flat and map methods. The need for a method that could both, map and flatten arrays in a single step became more evident with the increasing complexity of data structures in JavaScript applications, especially in a data-driven API world. FlatMap addresses this by merging mapping and flattening operations, making code more concise and efficient and less error-prone. So, if you haven't already, this is clearly the third video in my mini array architect series that covered from previous map and then flat, and today's video, FlatMap. So I'll be writing some code that I won't be explaining as far, mostly because I already did so in the previous two videos. So in the description down below, you're going to find a link to this playlist. Check out the previous two videos of map and flat for specific breakdowns on how and why they are written the way we do. And this video will make a lot more sense because we're about to craft our own. And it is a great highlight and showcase into how we can take complex problems like FlatMap and break them into smaller doable steps, i.e. map and flat specifically. So the purpose of FlatMap or its specs is to map each element using a provided function and then flatten the result into a single level array, right? So our input will be an array and a mapping function, for example, and our output will be a single level array resulting from the mapped and flattened elements. So the code, like I said, we're going to blast through it today. We have some examples. There's a CodePen in the description down below if you want to snag it and follow along or write it yourself, which I do recommend you do. As always, polluting prototypes in a real-world project, not a good idea. Interviews and educational purposes, adding new prototypes or messing with prototypical inheritance of the array object and messing and adding our own methods and whatnot is fantastic to showcase your learning, your command, and your mastery of JavaScript fundamentals, theories, and concepts. So here we go. We're going to write the easiest custom flat map you could ever think of. This is like cheating almost, right? Custom flat map is going to be a new array method that will be a function, and that function will take, at the very least, a singular callback. And all it needs to do is return this. Remember, in the context of JavaScript, this will get its meaning from where it's defined in functions anyway, unless you're an arrow function. So it's going to be running on an array. It'll grab its context from the thing furthest to the left, which will be the array itself. So this represents the array. All we got to do is put our callback into how we want to map this thing. Flat, we learned from the previous videos, will by default have a depth value of 1, and that is it. Now, this is a joke answer that I would probably write on a whiteboard in an interview. Read the room. Like, if it looks like you can have a little joke and discussion with your interviewer, whether you're on a Zoom call writing in Notepad or Notepad++ or something like that, or if you're in a room at a whiteboard holding an expo marker and you write this on the board, I would cheekily smirk and look back at my interviewers and be like, it's solved, because technically it is, and it does get the job done. So let's go ahead and take a look at one of the examples here. This is not where the video is going to end, FYI. Let's grab one of the split examples, and let's go ahead and take a look at it. So we're going to grab this one. Const r is going to be our array right there, and we're going to console log the r custom flat map. And again, eventually when I switch from custom flat map using this solution to our actual one, it should be the exact same output. We're going to take this and split each element, which is a string of letters, and we're going to take that and split it, a string of words, and we want to get the number of words from this sentence in this array here. Maybe we're getting some kind of sparse array in the real world as a data response, and we want to count the number of words that comes back from it. This is one way to do so, and we can see from the console log that is our expected output, which it's sunny in California. I grabbed this one from the MDN docs because finding simple, good examples of FlatMap was harder than I thought it would be. So this one's directly from MDN because this is where I started testing my own code implementations to make sure it was doing what it needed to do. So like I said, it will split this string of words into an array, but I don't want that. I want the individual words. So without the custom flat map, look what happens if I do just a map. We get a bunch of subarrays, and that's not what my intention is. Hence why custom flat map, or flat map in general, I mean just regular flat map, is the same answer we can see right there. So our custom flat map does exactly what it needs to do, and this is a solution that, like I said, read the room, I would do this and smirk at my interviewer if this was a question I was asked, and then it'd be like, haha, so you know the methods, good job, buddy. And then I would explain about the flat depth value, anything I could about the map callback, and passing arguments into it, whatnot, by doing this, callback dot call, for example, like we learned about in the map video and things like that. But again, if I wanted to answer this for real, then we're going to implement our actual versions of custom map and custom flat like we had learned. So like I said, these are done in previous videos, so I want you to go back and look at them for the technical explanations, examples, analogies, all the fun stuff that my little videos here entail about them. So this one had a result array. We returned that result. We had an IIFE, and I passed in this and the depth into it. The IIFE was a function that we happened to also just call flatten because we need to have recursive elements to it that represented the array and the current depth level in our recursive process. Here's the code block for this IIFE that was going to be a loop. Const element. This is where in that previous video I discussed we had to determine if the thing we're looking at, the element, is another array or not. We called it a box versus a book in that video. So we're going to say if the element we're looking at is an array and we have some traversal still allowed, meaning our current depth is not 0 or less, then we have ourselves a box we have to open, which is going to be called via flatten, our IIFE function right here. We're going to pass in the element, which is an array, and then we're going to subtract 1 from our current depth to know how deep down we're allowed to go. And by default, it is 1 level. So it only recursively go down 1 time. Otherwise, we take the element, whatever it is, and we push it into the result and return our result, and there you have it as our implementation of flat. So down here in .flat, I'm going to change it to custom flat, save the file with my autosave. I don't know why I have autosave on. I normally turn it off for this video series, but what are you going to do? Let's play it safe, so I don't get a bunch of errors all the time. There we go. And as you can see, the output is still correct after switching from the JavaScript flat method into my custom flat method instead, and we have our solution right here. So the next thing we need to do is, from the first video in this little mini series, is add a new array prototype called CustomMap. That was a function that took, and this was the clever part about this one, callback, and we needed access to this argument inside of our callback, which we had done by providing a specific context to our callback function when it is called. So just like before, we're going to have a resulting array. These are non-mutative. We're going to return that result after this is done. We do care about the index position and elements in this solution because we're sticking close to the actual map specifications. So we'll do this dot length I++. Then we simply pushed into the resulting array our callback function that we're going to call and apply, or rather call it with a specific set of context. So the first thing is the context followed by a comma separated argument. So now it knows that the context will be this arg, aka each element that we're passing in, and there you go. So now that has access to like x fat arrow x times 2, it knows what x is with the correct syntax. So there you go. There's our custom map, and I should be able to change this from the built-in map method to the custom map method, save the file, and the output is indeed the same. And now, as you can see, we have a fully functioning custom flat map comprised of a custom map and custom flat functions. I've done this in previous videos in this data and algorithms playlist I have going on, the Conquering the JavaScript Interview playlist, mostly because I do think it's very cool and important to showcase how to tackle complex challenges like FlatMap, which can often seem really daunting at first glance. This was the reason I didn't make this my first video and clickbait y'all and be like, hey, we're going to solve this. In the next two videos, I actually coded out the two parts beforehand, because the key to mastering these kind of complexities is understanding and practicing the smaller foundational parts that make them up. So our journey through map and flat, or custom map and custom flat rather, each of those methods are powerful on their own and represent a critical piece of a puzzle in understanding flat map or custom flat map. So by dissecting a complex problem into their smaller and simpler components, we gain a deeper insight into how the individual functions operate, and we also develop a strategic approach to problem solving. So if you could regurgitate this, what I'm telling you, as an answer to your interviewer about this kind of stuff, that's what it's all about. Like, they see that you have that developer's mindset. Now, it's easy to say out loud. It might even seem common sense to some of us, but again, we all learn and apply things differently. We all have our own contexts and lenses of how we view the world and life, and, our upbringing and environment shapes us in different ways. So, sometimes restating the obvious is important, or at least being able to define what I just said, that feeling, that mindset you already may have or may not have, being able to at least put it into words is important in an interview setting. Again, they can't read your mind, so being able to say something like this, I have this practice of breaking down and mastering smaller parts, which will cultivate a skill set invaluable in programming, right? It empowers us to build more complex solutions with confidence and clarity. So, when we encounter a multifaceted method like FlatMap, or if you get an interview question that's particularly complex, we can tackle it with ease, knowing it's just a combination of simpler elements that we are already familiar with. And this helps us practice how we can break down complex problems into smaller, simpler steps that build back up to solve the complex problem. All right, gives you a solid foundation that prepares us to solve even the most intricate coding challenges that eventually come our way. So, like I said in the top of the show, where we did this little implementation right here with custom flat map, we have an array of strings where some strings contain spaces which indicate multiple words, and this is a real world type of solution you might get. So FlatMap's role here is when we apply custom FlatMap with a split function, it first splits each string into an array of words, then custom FlatMap immediately flattens these arrays of words into a single array. This is probably one of the best examples of using FlatMap that I could have found for our custom implementation today. Without it, as you saw, we would end up with an array of arrays which each contain words, requiring an additional step to flatten it, whereas FlatMap makes it a one-step process. The other examples are a bit more contrived. Let's go ahead and grab them as well. From example 2, we're going to copy and paste it down yonder into our implementation. So I'll do const r2. And yeah, then we're going to console log r2.custom_flatMap, pass in that function there. I think I have too many parentheses. There we go. And then it should be our result of 1491625, right? So is that the expected output? Yeah, I mean, it's just, it's exponents, Luke. You could have done the math yourself. So 1 to the exponent of 2 is still 1491625. Yeah, so there you go. There is our implementation of that one. So in this scenario, we have an array of simple numbers. We are using it to reuse FlatMap is used to apply a transformation, basically squaring each number and then automatically flatten the result. Each number is transformed into an array with a single element, its square, and then custom FlatMap flattens these into an array. Again, contrived example, just showcasing that the square bracket syntax is indeed flattened or something like that, right? In the event that, like, if our transformation generates, like, again, like, we wrote this, but let's say we have a function or something in our code base that does some kind of transformation and returns an array to us that we don't want. Rather than having to mess with destructuring and weird stuff like that, we can just rely on FlatMap to get that job done. Like I said, it's not as fun as the first example, and neither is the second one here, but yeah, the role is just transforming an array of two elements or rather an element into a single one. So that'll be the same contrived example we have in the second one here, where our array and map that we have going on. So I'm going to change this to R3. I could have copied and pasted a bit simpler there, now couldn't I have? This one I can kind of tweak to show y'all some other things you could do here. So we can have R3.custom_flatMap. And that's our callback syntax. And yeah, we should get a single flattened array. So we even test the unpacking ability of our flattening function or flattening method in that we give it an array with 2 elements and it can still flatten it down to a single level array correctly here because we only have 1 depth level to traverse anyhow. So yeah, this takes a pair of numbers, the value itself followed by the value doubled. So it should be 1, 2, 2, 4, 3, 6, 4, 4, 8, and then 5, 10. So yeah, it basically takes each pair of numbers and returns the original number and the double version of that number into a single element array. Again, kind of a forced example. It basically is transforming into an array of 2 elements, the number itself and its double, and then FlatMap flattens the whole thing and returns it as a single array. Again, in more complex transformations where each element is mapped to multiple elements, it can elegantly handle the expansion and flattening, keeping the code concise and clear as needed. I mean, if we had some kind of function that returned to us coordinate pairs and we wanted an array of those coordinate pairs, it could be something more like that as well. So instead of winding up with triple array syntax, this one gives us returns to us an array of coordinate positions where one value is doubled from the next if you wanted to, and flat does the 1 depth traversal, which means we end up with an array of array structure like a matrix, which is a very common pattern. So again, these are just forced examples of how to use FlatMap here, but again, the real world, whatever data structure you got, if you're like, I need to go over this thing and flatten at the same time, which is something you encounter more regularly than you think, this is a great example of when to use it. So yeah. When it comes to data processing and code efficiency, FlatMap is where it's at. So I hope y'all enjoyed this journey through the FlatMap and our custom implementation of it, as well as the understanding of that developer mindset, taking complex problems, breaking them into smaller, doable steps like I did in the previous 2 videos in this playlist. That's where it's at. And being able to verbalize that same thought and feeling, I told y'all that mindset you have is what your interviewers want to hear and see when they give you complex problems like this. So this enlightened your journey in JavaScript. Hit that like button and subscribe for more content. I try and put out 3 videos a week, and my coworkers also try and put out content around this. If you have anything you're interested in seeing, hit me up in the YouTube comments, whether you had your own implementation of these things, questions about these things, or things you want to see, let me know. Otherwise, stay tuned for more episodes where I'm going to keep on breaking stuff down. I think I'm going to take a break from the Array Architect series and get back to doing some sorting stuff and then going back into general algorithms as I can find them, as I exhausted my personal list that I always gave students. So keep on coding, and I'll see you on the next one.